quite looking forward to making this video, and the reason for that is that I think this is going to be the most helpful video in the series, hopefully. And that's because it deals with what I think is the trickiest part of probability, which is working out which method to use. So I don't think the calculations in high school probability are very difficult. You have to calculate, you have to be able to use fractions, decimals, and percentages. But apart from that, there's not much going on in terms of calculations. It's mostly at a year 7 level. But the tricky thing, of course, is working out which method to use. Often you're looking at a problem and it's a whole heap of words and you just can't connect the dots. So this is a map. It's a 4-step guide to solving a lot of probability problems. So we're going to do an easy example and then we're going to move on to some harder ones. This easy example, you can do this without these fancy 4 steps, but I want to go through this so that we understand what the 4 steps are, and we can then apply that to the harder questions. All right. First step, find the sample space. So the sample space is, remember, all the things that could happen, a list of all the outcomes that could happen. So we can just look at the spinner and work out that there's 7 things that could happen. I could get any of these numbers from 1 to 7. And that's our sample space. Done. Find the probability of the outcomes in the sample space, step 2. All these sections of the spinner are the same size, and that's important because it means it's just as likely that I get a 5 as I get a 4, because the 5 and the 4 are the same size. That means if it's equally likely, then the probability of finding the outcomes, getting any of these outcomes, is just the same. It's 1 divided by however many outcomes there are, which is 7. And so number 2 is not too hard either. Number 3, find out which outcomes are in which events. Now there's only one event in our question, which is getting an odd number. So which outcomes are in that event? It would be 1, 3, 5, and 7, the odd numbers. Easy. Number 4, find the probability of the successful events. There's only one successful event, which is getting an odd number. So the probability of that event is how many outcomes are in that event, which is 4, 1, 3, 5, and 7, divided by the total number of outcomes, which is 7. And that's it. Okay, so this question, hopefully you can see, is quite easy, but that's the 4 steps and how they work. We're going to now work out, we're going to talk about some problems that we'll get with some harder questions. So here are our 3 harder questions, and here are the problems with each of the parts. And we'll kind of dip into some of these questions as we're going, just to show you examples of why they're harder and what we can do about it. So, finding the sample space is not always as easy as just looking at it, looking at a spinner and writing down the sample space. Sometimes it's a little bit harder. For example, let's say you have to flip a coin 3 times. So there's 3 stages. What you can do... Okay, so the problem is flipping a coin 3 times. You can't... It might be a bit hard to write down all of the outcomes. How do you even write it down? And how many are there, and what are they? So what you can do is you can draw a tree diagram for stage 1. 1, 2, and 3. So stage, I might do it over here so there's more space. There's 3 stages because you're flipping the coin 3 times. Oh, no, I remember I need some space over here. So tricky. Tree diagrams get out of control very quickly in terms of space. It's hard. Stage 1, 2, 3. Okay, stage 1, you flip the coin for the first time, so you get heads or tails. That's the options. Stage 2, you flip the coin for the second time. So heads or tails if you get a head first, and of course the same thing happens if you get a tail first. And stage 3, for each of these 4 outcomes, you're going to get another 2 each. And this takes a while, but you need to understand what's actually happening here, and the diagram's a really good way of understanding what's happening and using that to solve a problem. Okay, so now we actually have 8 outcomes, and it's not just the last ones that we're talking about. We're really talking about 8 paths, 8 things that could happen. You could get head, head, and tail, or you could get tail, head, then tail, and you can go down any of these paths. So there's 8 paths, and we're going to write down the actual outcomes over here. So H, 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 we'll write that as an outcome. That's one thing that could happen. H, H, T. All right, I'll hopefully speed this part up on the video. All right, so now we've got all our outcomes. Each of these is just one outcome. TTH is one outcome. And this is our sample space, the whole thing. So that's done. We've found the sample space for this particular question. Now, there's also another problem that you could have if you have a trial with a combination of parts. What I mean by that is, in question 1, we've got 2 dice, and you're rolling both of them. You're not just rolling one dice, you're rolling both of them, and you're adding them up to get an, so it's saying, oh, I haven't actually said that, have I? And add up the numbers. All right. So you've got 2 dice, you're rolling them and you're adding up the numbers. And it's a bit tricky because we don't know, we can't just write a list straight away of all of the possible combinations of numbers that we could get. And a good way to deal with this situation in the sample space is to do a table or another tree diagram. We could do another tree diagram for this, by the way. We could say, okay, I roll a dice the first time, I get 1, 2, 3, 4, 5, or 6. And then for the second die, I could get 1, 2, 3, 4, 5, or 6. You can see the problem with this. This is going to tell us all the possible things that could happen, but it's such a mess. It's so hard to draw. Now, we could also do this. Here's the things that we could get from our first die. And here's the things we could get from our second die. And hopefully you can see we can only do this table if we've got 2 parts that are combined. If we've got 3 die, we won't be able to do this. We'll have to do a tree diagram or find out some other way of doing it. Alright, so, and we're adding up the results. So what's in this table, this is all our outcomes, all the results that we could get. So if you get a 1 and a 1, you add them up and you get 2. If you get a 1 and a 2, you get 3. 3 here, 4 here, and I'm sure we could keep going, but we're not going to do that. But this is going to be our sample space, all of the things inside of here. And how many are there? There are 6 rows, 6 columns and 6 rows. So it's 6 times 6. There's 36 outcomes in the sample space. And to really find out what the outcomes are, you'd have to keep going, but we won't. We'll move on. Okay, so that's 2 ways of finding the sample space. If it's not really simple, like this, just writing the sample space down, we can use tree diagrams, or we can use tables. Either one. Okay, number Step number 2. Find the probabilities of the outcomes in the sample space. Now, the easiest way to do this is, let's say that they're equally likely outcomes. So if you have a big tree diagram and here's all your outcomes, and you know they're just as likely, then the probability of each one is 1 divided by how many outcomes there are. So this will be 1 over 8 to get H. Because if you're flipping a coin 3 times, it's just as likely that it's going to go down any of these paths. For getting any one of the things in these boxes, for example, getting a 2, that will be, the probability will be 1 over 36. Keep in mind, getting a 3, if there's 2 3s out of 36, because there's 2 boxes, that's going to be 2 out of 36. But hopefully you get the idea of how to do step 2 if all of the outcomes are just as likely as each other, which is the case over here. Now, if you have a tree diagram, you can also multiply the probabilities of the branches on each path. Like, you can write the probabilities here and multiply this one by this one by this one. We'll leave that for now. We only have so much mental capacity. We don't have to do that now. We'll do that in a video later on. Okay, so that's how to find the probability of the outcomes in the sample space. Number 3, find out which outcomes are in which events. Now, actually, for these 2 examples we've just done, the coin and the dice, this is pretty easy. Work out which outcomes are in which events. If we go to the question, let's start off with question 2. I flip a coin 3 times. What's the probability of getting at least 2 heads? This is pretty easy, actually, because we just have to circle, we've already written out the sample space. We just have to circle which ones have 2 heads, and at least 2 heads, sorry. And it's pretty easy to do that because we can see everything kind of pretty clearly. Which ones have at least 2 heads? That's going to be this one. There's 3, that's more than 2. There's 2 heads in this one, 2 heads in this one. There's only 1 head in that, so that's not part of the event. There's 2 heads in this one, and that's it. All of them have less than 2 heads. So we've just found out which outcomes are in the event of getting at least 2 heads. Let's look at the next one. Sorry, question number 1. I rolled 2 dice and add up the numbers. What's the probability of getting a number less than 3? So in this one, the event was getting at least 2 heads. In this one, the event is getting a number less than 3. Now, we don't actually have to work out the rest of the outcomes in the sample space. There's only one number less than 3, and that's 2. So straight away, we've already worked out there's only one outcome in this sample space. So we've done step 3 for these first 2 questions. Now, where it gets hard is question 3. Question 3, first of all, there's more than one event. That's the first thing that makes this trickier. There is 2 events. So 100 people were surveyed about color blindness and their favorite color. The events are, if you choose a person at random, one event could be they're colorblind, and the other event could be their favorite color was yellow. And so if you're asked this complicated situation, find the probability that a person picked at random in the survey liked yellow the best but was not colorblind. So if we're solving this question, a Venn diagram is very helpful because it helps us find the sample space, find out what the sample space is. It's like a little map of the sample space. It helps us find the probability of the finding the probability of the outcomes in the sample space is pretty easy. Each outcome is 1 over 100. But number 3, find out which outcomes are in which events. It helps us with that. So let's draw a Venn diagram here. And I've also said, by the way, if you've got 2 events and they're not mutually exclusive, which means they can happen at the same time, and these 2 events are not mutually exclusive because you can have favorite color as yellow and you're also colorblind. It's possible to be in the middle here. So anyway, here's our 2 events. Favorite color is yellow and colorblind. And now if we want to find out which outcomes are in which events, what we do is we just read the question and see if we can fill in the sections. So 100 people were surveyed about color blindness and their favorite color. So that means we know there's 100 in the whole Venn diagram. 12 people said their favorite color was yellow. Okay. And they were colorblind. So that means they're in the yellow event and they're also in the colorblind event. So where's the section where they're in both? That's here in the middle. So that's 12. Okay. So let's see. 20 people in total were colorblind. Does that help us? Okay, 20 people in total are in this circle here. That means if I've got 12 people in this section, there must be 8 people left over in this section. Okay. 70 people had different favorite colors to yellow and were not colorblind. So that means 70 people were outside of the yellow circle, but they're also not colorblind, so they're also outside of the C circle. So that means 70 people are out here. And that means, finally, that I can put the rest of the people in here. This is the only section left. So if there's 100 people in total, then this is got to be 100 minus 70 minus 12 minus 8. So if I add all these up, that's 70 plus 20 is 90. There's only 10 left over. Okay, so now we've found out which outcomes are in which events, and this makes it really easy for us to go on to step 4, which we'll do later on. So finally, with step 4, we'll finally solve these 3 questions. Find the probability of the successful events. That's what all these questions are asking. What's the probability of the successful events? So you can do a few things. You can add up the probabilities of the outcomes, which we've worked out the probabilities of the outcomes for a lot of these questions, or we can use the equally likely formula. So in this one, we use the equally likely formula to find out the probability of getting an odd number on the spinner. Let's look at the first one. Question 1. I roll 2 dice and add up the numbers. What is the probability of getting a number less than 3? So let's just tick off what we've done. Have we found the sample space? Yes, we've found the sample space. It's all of these. There's 36 things that could happen. Number 2, have we found the probability of the outcomes in it? Yes, we have. Each outcome is 1 over 36. Find which outcomes are in which events. Well, there's only one outcome in the event less than 3. Find the probability of the successful events. So remember, you can add up all the outcomes that are in the successful event, the probabilities, and that's just, there's only one of them, so that's easy. Probability is 1 over 36. Okay, question 2. Let's make sure we've done all the 4 steps for that one. I flip a coin 3 times. What's the probability of getting at least 2 heads? So let's see. Have we got the sample space? Yes. All of this is the whole sample space. Have we worked out what the probability of the outcomes is? Yes, it's 1/8 for each outcome. Have we worked out which outcomes are in the event? There's only one event, so getting 2 heads, and we've worked out there is 4 outcomes in that event. Finally, it's easy now. Find the probability of the successful events. That is 4 divided by 8. Because there's 4 successful outcomes, which is these 4. And there's 8 outcomes in total that are all equally likely. So that's a half. By the way, if this is getting too complicated at any stage, feel free to pause it and just think about what's happening for a little bit. And you can rewatch some sections. Okay, number 4, find the probability of... Sorry, what am I saying? Question 3. We're up to question 3. Okay, so ultimately what we're trying to do is find the probability that a person picked at random in the survey liked yellow the best, but was not colorblind. So we've drawn a map of the sample space. We've got which outcomes are in which events. We know that there's 100 people in total, so the probability of each outcome is 1/100. And by the way, you can kind of skip number 2 sometimes, but not always. Okay, and number 4, find the probability of the successful events. Basically, we're trying to find the probability that a person picked at random liked yellow the best, but was not colorblind. So what we have to do is work out how many outcomes are in that section. The person who liked yellow the best, but was not colorblind, that would be inside the yellow circle and outside the C circle. So they liked yellow the best, but they're not colorblind. They're not inside this one. So that would be this section over here. And we know there's 100 in total, so the successful outcomes, there's 10 of them. And the total outcomes is 100. So the answer is 10 over 100, which you simplify the fraction, you get 1/10. And this is going to be 1/10. All right, so hopefully, now I'm sorry that was so much information, but I thought it was really important to get an idea of how to start these questions. Hopefully now if you see different questions, you'll have some idea of what to do. You have to find the sample space first, then find the probability of the outcomes. Sometimes you can skip this part. Find out which outcomes are in which events, or at least find out how many there are in the different events. And finally, find the probability of the successful events. So I hope this was helpful. Write a comment if you were confused about anything. And thanks for watching, and I'll see you next time.